Okay, welcome to the Sacred Heart Career Academy botany classes. So we will continue and again we will solve some question and discuss. So our one question that from the translation itself that guard cells are double set in monocot. Cellulose microfibrils are arranged radially in the guard cell. Inner wall of the guard cell is thin and elastic. Guard cells are guard cells are surrounded by subsidiary cells. Okay, here we have to find out the incorrect statement. The guard cells are double set in monocot. This is that in general that the guard cell we see that is the kidney bean shape or reniform. These are that is the general and it is mostly present in the dicot, okay, and other monocots also. The guard cells are kidney bean shaped. It is curved structure. But in case of grasses, the guard cells are different. Guard cells appear like the dumbbell like. Okay, this is like your exercising dumbbell. Okay, this is the shape of the guard cell in case of graphic, and in this case, the not the inner wall is thick. Here, inner as well as outer wall of the guard cell in this case are thick. In grasses, the wall of the guard cell is thick. Whether it is inner or outer, and their end, which is a spherical ball-like structure. Here the walls are thinner, so it is dumbbell shape and it is found in the grasses. So guard cells are dumbbell shape in grasses. Here the inner and outer wall both are thick. Cellulose microfibril. So this one is correct. This statement, cellulose microfibrils are arranged radially in the guard cell. That's what we have learned in the previous one question also, that this cellulose microfibril, their orientation in the guard cell are radial, so that their diameter does not increase much. They should increase in their length. This statement also correct. The inner wall of the guard cell is thin and elastic. This inner wall, not the inner wall, it is the outer wall of the guard cell in general. Outer wall of the guard cell is thin and it is elastic, so that it can expand more. Okay, so this expand, and this inner thick wall, which is not much elastic, so their structure helps in the bending of this guard cell at the time of opening. The guard cells are surrounded by neck, so this statement is incorrect. It should be inner outer wall is thin and elastic. Number 4, the guard cells are surrounded by subsidiary cells. The guard cell, actually, this is guard cell. Surrounding the guard cell, there are some epidermal cells. Their number may be 2 or more, that epidermal cells surrounding the guard cell. These cells are known as subsidiary cells. The number of subsidiary cells may be 2 or it is more. Sometimes it is in one concentric ring, sometimes 2 or more rings also it is found. In some plants, the subsidiary cells are quite different from the other epidermal cell of the leaf, but in some cases it is quite distinct from the rest of the epidermal cell. So this statement also is correct. This is correct. This is correct. So here the incorrect statement is the number 3. So our answer is number 3. So this is our answer. So the incorrect one is the correct answer. This is number 3. In the grasses, this a special type of guard cell. Here, what happens that when this is the double septal structure, at the time of opening, when the water moves inside the guard cell, then this portion, this thin, narrow central part, this cannot expand due to their very thick wall. But this ball-like structure at the end, their size, their diameter increase, and these things make these two cells little apart, and so the central pore, that is the stomatal pore, this stomatal pore that opens. So in the classes, the stomata is little different. Next question, opening of stomata is due to turgidity of guard cell, size of the guard cell, number of guard cells, and number 4, the amount of carbon dioxide in atmosphere. So it is the very simple question, this one. This is this size of the guard cells or number of guard cells or amount of carbon dioxide. These are not related anyway with the opening and closing of the stomata. It is the turgidity of the guard cell. So movement of stomata, we can write also that movement of stomata is due to the change in turgidity of guard cells. So it is the turgidity change. When the turgidity increases, the stomata open. When turgidity decreases, the stomata closes. Higher the turgidity, the stomata open wider, and that's called the increase in the rate of stomatal transpiration. Now, the question from the absorption of minerals. Minerals are mostly absorbed by active transport. Number two, facilitated diffusion. Number three, by simple diffusion. All of the above. With mostly, here it is mostly absorbed by. Minerals are mostly absorbed by. Of course, the mineral salt, which is absorbed in the form of iron from the soil, they are absorbed by different methods. They are absorbed by diffusion also. Sometimes some of the minerals are absorbed by diffusion. This maybe facilitated diffusion. Okay, these are the captive modes of the transport, passive modes of absorption. But these mineral elements are mostly absorbed by active transport mode. What is this? There are two transport modes. One is passive and another one is active. In the passive mode of transport or absorption, passive mode of absorption, it is with no metabolic energy. Is sustained. So the movement of the mineral, entry of the mineral within the plant, there is no energy, metabolic energy here. That is the expenditure of ATP. ATP expenditure is not required, and in this method, the minerals and substances they move along a concentration gradient. If the concentration of the particular mineral is very high in the soil solution, then it will move into the plant. But it has been observed that plant stores very high amount of mineral, iron, different elements within the plant in compared to the outer solution. So in those cases, this absorption is not passive. Most of the absorption of the elements that takes place by active method, and in active method it is metabolic energy with the expenditure of metabolic energy. So ATP is spent, and this ATP is coming from the respiration. So it has been seen that when the plants are absorbing mineral salt, then their rate of respiration is increased. Usually, if a plant is transferred from the pure water, from the distilled water to a solution of salt, then it has been observed that the rate of respiration in the root is increased. This increase in the respiration rate is for supplying ATP to the process of the absorption of minerals. This increase in the increase the rate of respiration due to salt absorption sometimes is known as salt respiration. As it is, the energy is spent, so plants can select and mineral ions are absorbed against concentration gradient. Here it is against concentration gradient. That's why plants can accumulate more particular element than its outside solution. So it is active mode. The question is passive absorption of water by roots. System is the result of tension of the cell pad due to transpiration osmotic force in the food system. There is the passive absorption of water. Water absorption also, there is passive mode, active mode. And most of the water is absorbed by the plant in the passive mode. Passive mode of absorption is faster than the active mode of absorption. Okay. This passive absorption of water by root system is the result of it is due to the continuous transpiration. The transpiration, the continuous transpiration, that is the continuous water loss by the plant in the root system, that creates a tension, okay, a pull in the water column. And this tension from the root system is transported to the root system, and the root, particularly the root here, absorb water. So it is that what we also call the transpiration pool. Okay, so passive absorption of water is high, the root system is perfect. The transpiration will cool. Osmotic forces, force created in the cells of the root or increase the respiratory activity of the root cells. These are the active mode of, these are explanation for the active absorption of water. Let us see something little bit that the passive and active water absorption. The water is absorbed by the root, and in the root it is the root gas. Okay, the root gas was suitable for the absorption of water. What causes it? There are various theories used by the physiologists, but this only that is the passive mode of water absorption. Mode of water absorption has been supported by many physiologists. Others, all these views, they have been kept under active mode. Active mode of water absorption. What is passive mode of water absorption? When the plant is absorbing water, it has some force is there which causes the entry of water into the plant. So particularly into the root. So what is that force? Force is produced within the root cell, or force is produced somewhere else. So this is the captive mode. Suppose that the forced part was absorption of water. Water develops away from root in the shoot system. That is, the force which caused the absorption of water, that force doesn't develop in the root system, but it develops away from the root in the shoot system. The roots are only the gateway to which the water enters, but the root has nothing to do on pulling the water. This passive mode believes that. And here, this has a lot of support, and that's why we can find that sometimes the cut flowers, the branches, cutting, branch cutting, remain fresh for many days when we keep it in water. But those portions, they don't have roots, but still they absorb water. Okay, so that's this thing's normal behavior, that it explains that the roots are not essential structure for the absorption of water. The force is developing somewhere else in the root system. Okay? This rate of water absorption, is very high through the passive mode. And usually it has been found that the rate of absorption and rate of transpiration of water and rate of transpiration of water is roughly equal. It is because that the transpiration is involved in the absorption of water. So when there is a rate of transpiration is very high, the rate of absorption also increases. And this process is very fast. Plants absorb maximum water by passive mode. water absorption. Active water absorption means that the force for absorption of water by plants or the roots is the activity of living cells of the root. It is the activity of the living cells of the root. So that's called the absorption of water. This can take place by osmotic method. Osmotic process also it can take place, or it can take place by non-osmotic also, but it is the activity of the living cells of the root. The plant absorbs water by both the vessels. Active method of water absorption is very slow. That cannot meet to the requirement of the plant. This is very slow. Passive mode is very fast and it is in mass. Then that is mainly composed of water and glucose. Water and fructose. Water and cellulose. Water and sucrose. The fluid fat, that is the solution which is found in the phloem tissue, particularly the components of the phloem that is in the feed tube. Feed tube are the main components of the phloem tissue, and through this phloem, the organic food material is transported, and this movement is, as we have learned also, that it is bidirectional. What happens? What is the composition of the phloem? Whether it is water and glucose, water and fructose, water and cellulose, water and sucrose. So here, these two, glucose and fructose, they are monosaccharide carbohydrates. They are mono right, and this one cellulose and sucrose is the disaccharide. The monosaccharide, or this one is polysaccharide, this is disaccharide. Of course, the cellulose will be major component of the plant cell wall. Actually, what happens, the plants carry out photosynthesis. This photosynthesis, through the photosynthesis process, the carbohydrate which is synthesized first, they are glucose and fructose. These are monosaccharide. In the plant body, the carbohydrate is stored for the future purpose in their storage organs, like food, in the food and other part of the plant body. The carbohydrate is stored. The stored carbohydrate is usually a starch. And a starch also is a polysaccharide. This is the stored food material in the normal in the plant cell. But when this glucose and fructose is transported through the phloem, at that time they are not transported in the form. They are transported in the form of sucrose, which is disaccharide. So in the phloem cap, in the thick tube, we get a solution which is water and sucrose. So in the plant, the food is synthesized food synthesis in monosaccharide and when it is transported, it is disaccharide and stored in the polysaccharide form. The storage, in the storage, it is polysaccharide. When it is transported, it is disaccharide. When it is synthesized, it is monosaccharide, glucose and fructose. How this transportation of the food material, organic food, takes place from the leaf to the other part of the plant. Because there are several views are there. One of the theories which is most accepted for the translocation of the organic food material is the fluid tissue. That is, on that we have a question. This is the question. The crystal mechanism for translocation of sugar from fork to thin, from fork to thin. Here, one is pressure flow hypothesis. Number two, mass flow hypothesis. Number three, translocation pull hypothesis, translation pull theory. And number four, given both one and so here first we should know what is force, what is think, from force to think. Force is where the substance is produced and it is supplied from there. The center from where a substance is synthesized, produced and supplied. So that is the force. Note this, in case of this organic food material, the force is the green leaf. That in the leaf, by photosynthesis, food is organic food is produced. So the leaf is the green leaf is the force. And think is the place where the product is consumed, utilized. Think where it is utilized or stored. Okay? So here in the plant, the force is the green leaf, the think is all the non-green parts of the plant. Okay? Particularly for the leaf, that comes to the root. Or any of the exploded doctrines. Fruits are also, flowers are also the tree. Roots, the same odor, branches, the same, their fruit, seeds, all these are the trees. So this goes through the process that is known as, very popularly known as mass flow hypothesis. Because this organic food and transported in mass, in a large quantity, and that's why it is called this mass flow hypothesis. And it is under a pressure. Okay? And that pressure is the surface pressure. Okay, surface pressure. So due to this surface pressure, the pollution, that is pollution of the fluid and water, that is pushed down here. So it is also known as surface fluid. That is under pressure, under surface pressure, it goes through this growing tissue, and so it is also known as circulation flow hypothesis. So our answer is both 1 and 2. This mass flow hypothesis is also known as Moore's hypothesis. Okay, so we will end here today. The next class, the middle part